sound engineers does it take to change a light bulb? Let me check. 1, 2, 1, 2. There we go. Context. So has anybody thanked the organizing team yet for Ruby on Rails? Well, thank you. This is a super fun conference every year. This is actually my second year at Ruby on Rails. And how many of you are from Bend? Okay, so you all know how to drive on rotaries and Dodge SUVs and the one-way roads and everything? Yeah, this is actually my third time in Bend, and I drive up here every year from Seattle. And I get lost every single time I leave the conference venue, try to get back to where I'm staying. Which reminds me a lot of my home. I'm originally from Vermont. It looks exactly like this. This bridge is about 1.5 miles from my parents' house. The entire state is this beautiful, pristine, historical monument. Every year, hundreds of thousands of people come from everywhere on the earth to see our foliage. And getting around Vermont and getting around Bend is very similar to me. The joke in Vermont is if you get directions from a Vermonter, this is usually what you get. If I have a couple more beers, I'll actually be able to say that properly. This is a map of southeastern Vermont, where I'm actually born. I was born and raised in Brattleboro there down the bottom. But if you ever come and visit, and let's say you started in Putney, Vermont, which is a beautiful town, it's where my parents' farm is, and you hear about this awesome organic milk tasting that's going on in Brookline, Vermont, over there. It's amazing, and you want to get over there. But you don't have a map. You're not going to have Google, because we don't have Wi-Fi. We have 1G coverage, I think. But you manage to get some directions from a local, and you figure out that you have to go down there to Brattleboro and then come back up to the West River Valley. And it's pretty easy, right? It's pretty simple. What probably most of you don't know, because you don't pay attention to Vermont very often, is that about 2 years ago this happened. Hurricane Irene came through and dumped about 8 inches of rain on the state. Not a lot of rain. Vermont is shaped like a wad of tinfoil that got crumpled up, and then someone kind of tried to flatten it out again. So roads galore, washed out, whole towns are wiped off the map. It's kind of a disaster. So you hit this, and you turn around, and you find some farmer, and you interpret his directions, and he says, the classic, 2 miles before the dead end, you want to take a left. And then you head a ways, 5, maybe 15 minutes, to where the Hitchens place burned down in '53. Can't miss it, take it right there. And it's going to be your 7th left after the white farmhouse. Classic Vermont directions. You can't get there from here. But eventually you do, and you figure it out. So you suffer a little, and you had a little bit of adventure in my home. You learned a viable route between point A and point B, and you saw some pretty leaves. Oh, and you got to taste the milk. You got there before they closed. That's good enough, right? Probably. That's good. You're just a visitor. You're a tourist. Please come. Give us your money. But what if you lived in Putney and you had to go to Brookline every single day for work? Is there a quantitatively or qualitatively better route to take between these 2 points? Obviously, because I'm asking the question, there is. This road right here, this is Putney Mountain Road. And it's only called Putney Mountain Road by people who know that it exists, because there's no signs. It got its name a few years ago because they brought 911 into the state, and everybody has to have a name. Every road has to have a name. But you're not going to find it on maps. I guarantee you Google Maps isn't going to find it. iOS maps certainly aren't. It's only open about 8 months of the year. The rest of the year, it's not even plowed. It's snowy or muddy. If you got a 4-wheel drive, go for it, but whatever. But it's going to shave 20 minutes off every time you go from Brookline to Putney, or vice versa. It's a classic country shortcut. We write code, we get the tests working, then according to Sarah, we go back and we write some more tests. But eventually comes time to refactor. Or maybe we're just staring at a mud ball of code, and every time we touch it, little pieces fall off, and exceptions get thrown, and bosses get involved. We need to figure out how to make the voyage from A to B, from initialization to final output, better. We're trying to refactor. We're trying to fix it. We want to get better. If it's a car trip, this is really, really easy, right? Once we get where we're going, now we know. We asked some locals, we've got some reference points. We know we can't go up West River Road. How do I know when my code is good enough, though? Where's the guide then? Maybe I have a new client and they give me an 80,000-line legacy Rails app that has 18 other developers who've worked on it and quit in frustration. It's mine now. Where's my map? Code metrics can really help with this problem. They act as compass, GPS, local guide, location-specific survival kit. They're not going to get you to your destination. They are going to help turn this voyage through uncharted regions into just a random trip across the ridge for milk. When I was actually first thinking about this talk, I pitched it to a coworker, and he said that, that sounds really good, but you're selling vegetables. You're telling people to eat their vitamins, be better. And you should eat your vitamins. I'm a Vegemositarian, so I kind of like vegetables. But that's not the point of code metrics. You all know that you should eat vegetables. You know you can do better code. And you probably know something about some code metrics tools. Maybe you actually got metric foo working sometime. Actually, has anybody ever used metric foo? Did you get it working?
Barely.
Okay, I want to talk to you later. Can't get it to work. So maybe you got that working, or maybe you use Code Climate from Brian Helmkamp. Yes, great tool. And you got some sort of metrics tool running, and then you're going to experience this, which it's pretty classic 5 stages of mourning, loss. But really, probably you experienced it in this way. You get sad. My code sucks. I'm getting an F somewhere. So you decide to fix it. You bargain with it. And then you get angry because somebody on your team wrote some bad, shitty code. And then, okay, someone on my team wrote bad code. That's okay. Nobody's perfect, especially not my shitty coworkers. Big love. So you commit a fix, and you never look at code metrics again, ever. And the reason you don't is because you've been told that you're bad. This cold, unfeeling program, this robot, came out of nowhere and just pissed all over you and your team and what you do. Said you're bad at it. So why should you actually go out and seek out this harsh, judgy judgment? You've probably heard the quote that programs are meant to be read by humans and are only incidentally for computers to execute. We're writing code to communicate logic, intent, work that needs to be done, and these tools don't have hearts or feelings. They don't really think that you look funny or smell bad or any way, shape, or form. They're just there to tell us something about our code. They're trying to tell us that we may not be communicating to our team members or to future developers exactly what we think we're communicating. Who's read Wise Poignant Guide? A lot of people? Just a few people? Okay. Sorry, by the way, this is interactive. I ask a lot of questions. One of the things that Wise said that really stood out to me when I first read it was that a block of Ruby code could be read aloud, and people are able to understand it. Ruby's a very literate language in a lot of ways. It's very expressive. Does anyone want to volunteer? I'll give you the mic right now. You can come up here. No? Okay. This isn't the worst code that I could actually find in one of the apps I work on right now, but it's pretty bad. I actually, last night, tried reading this out loud. I don't know what it does. I mean, I can figure it out. I'm not dumb, but read aloud, it doesn't say anything. You can't just look at this and gather what its intent is, what it's trying to do. There's three, four different levels of abstraction going on here that have to be kept in someone's mind at the same time. And you know who wrote this piece of crap? Yeah. Obviously. Code metrics aren't about eating vegetables, and they're not about forcing us to do something right. They scold us a little bit, of course, when we stray from their particular vision of good, but they also serve to change our context for looking at our code. This is a card from the Oblique Strategies deck, which was a deck of cards made by Brian Eno and Peter Schmidt in the 70s. They were just hanging out in the studio, and Eno's playing some music, and Schmidt's painting. He's a painter, and this is what you did in the 70s. And they wrote down these little cards, ideas to shake up their creative process. This is one. Some other ones are use an old idea, emphasize the flaws. What would your closest friend object to? Code metrics serve the same role oftentimes because they can change our context when we look at our code, and they can jumpstart these creative approaches and start conversations on our teams and with our peers about what is good code. It starts conversations with ourselves. Am I good enough? How can I get better? What's the road to that? But how do you actually use these tools? How can they improve your process through a TDD process? Everybody test first? Yeah, always, right? Yeah, totally. So you write code, then tests? A few people, maybe? Okay, does anybody have 100% test coverage? I always want to know. Nobody?
On everything or one thing?
Who has 110% code coverage on something? How about 80%? Okay, who knows what their code coverage is? Okay, awesome. You all are on the first step because you're all using a code metric. Given our obsession with testing, test coverage is usually one of the things that we kind of know about. It's one of the first go-to metrics that we talk about. We don't even think about it as a code metric, as a way of looking at what our code does and how it exists. It's usually one of the first things that you run when you get a new piece of code that you have to work with. Now, there's 3 ways that we calculate code coverage: C0, C1, and C2. And for the most part, in the Ruby world, we focus on this first one, C0. If you run rcode or simplecov, this is the number this is how it's the technique that's using to generate its numbers. 100% coverage doesn't mean anything, as I'm sure you know. It's entirely possible to write tests that will get you to 100% coverage without writing a single assertion, right? It's just about lines of code that are actually executed. Doesn't mean a thing. At this point, I think I'm obligated to say, what's the right number? I don't know, and I don't really care. What's the right number is what's right for you and your team, and that's the truth for all of these metrics. When it comes to code coverage, DHH calls it security theater. Uncle Bob says, of course you're going to get 100 if you're doing TDD, right? But it's really up to you and your team to figure out what TDD, or excuse me, what your coverage metrics are going to be. Same way with all these other code metrics. Maybe you like complex code, maybe you don't. It's just that code coverage, test coverage numbers are just too easy to bullshit. Lines of code is another thing that's just too easy to fake. Lines of code used to be used to measure developer productivity in the dark, dark days of 2012. It's just a simple accounting of the number of lines of executable code within a code base. There is a rough correlation between the number of lines of code in an application and the rate of defects. Obviously, the larger the application, the more chance there are for defects. But really, if you're ever in a place that's using lines of codes as a metric that you have to change the needle, you have to move the needle on, you should run. Update LinkedIn. Don't worry about what your coworkers think. A lot of people run rig stats from time to time. This is actually a pretty opinionated stats tool. It doesn't show you anything about your views, doesn't show you anything about the JavaScript in your application. It's so high level, it's almost pointless in a way. It is one of the first commands, though, that I run when I get to a new application, just because it gives me such a high level view. Is this a service app? Is it nice and slim and tight on controllers? What's that?
I like that one model spec with 1,069.
Oh, don't worry, I'll get to that. Good eye, though. This is the kind of metric that I like to run, and it's kind of like, I liken it to if I've got a crap-filled garage that I've got to clean up, and you kind of go in the middle and you look around and you're like, okay, I'm going to need some boxes and a mop, and I think there was a cat in here at some point, so I'm going to need some gloves. It just kind of gives you sort of a general sort of sense of where things are. By itself, though, it doesn't really tell us a lot. Code coverage and lines of code, though, demonstrate the 2 different kinds of code metrics that we encounter. Calculating lines of code is a static analysis process, and it's performed without evaluating the code at all. Dynamic analysis, obviously, is the opposite of that. It actually runs the code and watches its performance, or it benchmarks its time, or some characteristic about its behavior is tracked. There are far more static analysis tools available to us in the Ruby world. But static analysis tools never really understand the code. They're really, in a way, very complicated regexes that sort of look for patterns in the shape of the code. And then they just sort of spit out a number or rating or a chart or a grade. Static tools might, though, indicate problematic code. And that word might is really, really important. Static analysis will usually return a fair number of false positives, unfortunately, because it is just a regex. There might be a really good reason for there to be empty rescue blocks that just capture all the exceptions and shove them down. There might really need to be complicated metaprogramming blocks somewhere. Sometimes code just has to be duplicated. It's up to you, you, the developer, the human, to figure out what these numbers mean to you. If you're ever in a position where you're trying to code with the aim of passing some arbitrary threshold in the code, you're kind of wasting your time. These are just helpers to find possibly problematic code in your code base. The metric I use most these days, though, is complexity. I work on a lot of legacy Rails apps. And roughly speaking, this is a decent measurement of how painful it's going to be to understand a piece of code. There are three basic forms of complexity. There's cyclomatic complexity, which was proposed by Thomas McCabe. And it's the count of the number of linearly independent paths through the source code. I knew I couldn't land that. I could not stick that word. Methods with more paths through it are harder to understand. There's simply more states that it could exist in that you have to pay attention to. The number of linear paths through the code, though, however, is going to track really closely to the number of unit tests you probably should be developing, because each new linear branch is an inflection point or a functional point within your operation. Well, that's one kind. The second kind is assignments, branches, and conditionals, or ABC complexity. Assignments, foo equals bar, branches, function calls, class methods. Conditionals are logicals and booleans. Fog is the one that most of us use, though. It's the highest profile, certainly within the Ruby world. It's a very opinionated ABC complexity score. It counts the number of assignments, branches, and conditionals, and then penalizes you for metaprogramming using complex things like eval. Good FLOG scores tend to be around 10 for models, 20 for controllers. That's the general guideline. I spoke to Ryan Davis, and that's pretty much his hard and fast opinion. If you ever run FLOG and you get a complexity score of about 60, you really want to fix that right away. Fun fact, though, the highest, for those of you who use Code Climate, the highest FLOG score ever recorded on Code Climate, 11,354. Yeah, I didn't write that one. That one wasn't me. Like most code smells, though, high complexity is a pointer to a deeper problem in the code. Now, it might just mean that you need to break out the extract method pattern and just mash it into place. But sometimes it means that you're going to have to rethink your domain model. Maybe the original developers didn't really understand the problem space, and we're going to have to decompose this object and restructure things a lot. Sometimes. It depends. Frack. So if we step to back up to a higher level for a minute, churn is absolutely fabulous. And what it is it just looks at the number of times, it looks at your version control system, and it says this file for a given time period has been changed this many times. Understanding where your most volatile code lives is an amazingly useful thing. It helps you identify brittle code, business critical areas, the so-called God objects, kitchen sink, dumping grounds, and again, where you don't understand a problem, where you're constantly having to come back and change it and change it and change it to refine your understanding. Here's the churn values for a pair of files in one of my apps. Pretty much, they're the same value. Only by comparing them to the rest of the application can I really understand whether these are high velocity or low velocity files. This is the Wonderland Trail. Anyone hiked Wonderland Trail at all? Thank you. You were, both of you, 3, 4? Cool. I really want to hear about your trip sometime. I'm not in the best hiking shape anymore. I used to be. I used to be a long-distance hiker. But someday I really want to hike the Wonderland. It runs around the base of Mount Rainier. And the halfway point is it's about 47.2 miles from arrow to arrow there. And I could do 10 miles a day. I mean, it's walk 2 miles an hour. It's 5 hours of walking that way. And then you put up a tent, and you do it the next day. You do that 5 days, and you're back at a parking lot. That's pretty simple, right? It's not so bad. If you haven't seen it before, this is an elevation graph. The peak there at the very, very tip top is 6,000 feet. The lowest trough is just a smidge under 2,500 feet. I don't want to walk up and down that. My knees hurt just thinking about schlepping a 15-pound pack up and down volcanic ridges all day for 5 days. Just like the raw churn number, the raw number of miles here is misleading. What happens if we take another stab at looking at those churn numbers, though, with adding the dimension of time? The user model's changed a lot. It's the one in green. I see 3 distinct areas, 2 big ones and a couple little tiny ones where it's been changed. Those are probably somebody working on a new feature or doing a major refactor of the code. The invoice model in blue, that's a mess. That thing is changing every 2 or 3 days. It's not CSS. It's not a config file. It's not a gem file. It's not a translation file. What the hell is going on with this file? We have to find out. Because sometimes a churning file is just one of these configs. But the amount of frequency that these occur at really should give us pause. Sometimes these complex files are just junk drawers, the omega messes that we have to shove things down into. And sometimes they're problems. By itself, churn isn't going to tell you too much. It'll give you the tempo of a project, but it's going to reveal some possible problem areas. Once we start mixing in other metrics, though, that's where it starts to really, really shine. This is the output of a gem called Turbulence by Chad Fowler, and it's based on a few other people, Corey guy. It's based on a blog post by Michael Feathers where he proposed starting to mix together code metrics to give us better understanding. And this is graphing complexity versus churn rate. A piece of code having a high complexity implies a high rate of errors, because every time somebody comes into it, they're likely to break something. So the more often that you come in and touch something that has high complexity, the greater and greater risk you're going to have for these bugs, because we're lazy. It's much easier to just tack on another else if instead of actually going in and refactoring. So we run this for a project. And sweet baby Jesus. OK, this is a crazy pants file. I ran Turbulence, and this is what it spit out. And I said, oh, man, there's this huge outlier. I wonder what's up with that. And I looked into it. Its complexity is over 1,600, and its churn rate is about 1,000 for the last year. It's clearly a candidate for some kind of love and attention.
What is it?
I'm sorry?
What is it?
It's actually a model file, believe it or not. Yeah, I mean, obviously, somebody didn't know what the hell they were doing when they wrote this. So I really like this tool a lot, and it gives you a really, really good snapshot. But this outlier was almost too easy to miss. So I usually like to pipe this output into a tree map. Here, the size of these squares, each one of these squares is a file. The size is the relative churn rate. The color, green is good, red is bad along the spectrum for the amount of complexity in the file. So this is like an idiot light on our dashboard of our cars. We're driving around Bend, and shit, I got to check the oil. Check engine light. What's going on here? I've got to take this thing into the shop, though. This is bad. I wonder who wrote it. So I probably have to decompose something. So I break out flog, and I run it. This is the top part of the output. It looks like we've got 4 large God objects that are doing a lot of stuff that's really interesting. Flog lets us actually, has a show details flag that we can throw in to actually see what's it complaining about. This goes about, it sort of bins up its different score values. There's a lot of branching. Assignments are going crazy. We're probably playing some, the brackets there are saying we're playing some array games, probably a lot of maps and collects and selects. Ticket and user appearing here. I know that ticket and user occur in my code base as other models, so I probably have some log demeter violations where I'm reaching over into these other things and pulling them out. I can probably fix this particular method with the extract method hammer. So boom. Now everything's nice and simple, right? Except now I've got a lot of duplication. So I run the flay tool on it. It shows me I've got a bunch of these methods that are repeating similar tactics of sending out email. Again, this is the send notification thing, so obviously a lot of problems there. When I get done with this, though, I look at this, and I've now taken a file that had 12.5 methods, and now it has 30. And all of them are now private and only work with this one send notification, so that should probably get thrown into its own service model. So I juggle this stuff around, and now I've got a nice little service object. And I do a few more rounds of refactoring. And, excuse me, subscription is much, much slimmer now. So I hop back to my tree map to see how am I doing with the project as a whole. And now ticket is a problem. Right now, that's the next one I have to face. But I don't have to do that today. That's someone else's problem. They're on hot seat. So this is a little bit of a canned exercise, obviously. But I hope it demonstrates a little bit of like my personal work pattern. Where I use these tools to sort of see at a high level, where are the problem spots? What do I need to focus on next? Because when you're in the middle of it, when you're in the shit, you get numb to the crap that's going on around you. It's no longer super obvious that you have a 100-line method. You just open the file and you're like, I got this story and I've got to like have it send this other thing. Okay, if it's type this, send this other thing out. Or, well, I can solve this with some crazy metaprogramming, and you do it. But you're just adding to the problem if you don't step back and look at the higher level vision of where your code is going. For myself and my projects, again, I work on a lot of legacy apps, so churn and complexity are really the go-tos. These are the things that I look at every day. And I think they have a lot of application, even for greenfield development. You can sort of track, see what's the trajectory of this project. Where are things starting to show up? Where is it starting to go bad? Sniff the milk, if you will, and see if it's kind of a little off. The more you gather and pay attention to metrics, the more they're going to speak up and clue you in on where these problems are. So I talked about size, code coverage, churn, and complexity. There are a few other tools we can use. I mentioned briefly in passing the flay gem. It's a syntax tree duplication detector. It goes through and it analyzes the syntax tree of your code. And using some fuzzy matching, it identifies blocks that are extremely syntactically similar. So maybe you can kind of compress those down. You could dry up your code a little bit. Of course, you don't want to get too dry because then you start to chafe. With flay, you get a lot of unfortunate false positives from if you have a very RESTful, cruddy Rails application, you're going to get a lot of duplication in those controllers, for example. It's just a side effect, and it's an unfortunate thing, but we can make the tools better. We have the power. There's a number of best practices and style gems and tools out there. Some of them just look at specific code smells. Rails best practice and Reek do that. Some of them look at our object-oriented design. Rudy and Palooza do. Palooza is extremely configurable, but also extremely opinionated out of the box, and it only runs on Rubinius. So some of you might have a problem with that. Cane is a really interesting one in that it examines code style. It analyzes for white space, line length, that sort of thing. It also measures APC complexity, and it looks for documentation in your code. Are you actually documenting as you go along? I take it you don't. Does anybody here actually document as you go? Okay, yeah. Good code documents itself, I guess. Cane was originally developed at Square by Xavier Shea, and he noticed that his code was starting to look crappy, and so they wrote this, and it runs in their CI build. If anything, if the number of violations gets too high, it'll actually fail out, and so you wire into a CI build, and it'll fail your build if somebody checks in some crappy code. That's kind of cool. I use it once or twice a week to sort of see, because I can't read every single code commit that the rest of my team writes, so I read it to sort of see, like, are we moving in a good direction? Do I need to pay more attention to code reviews for the next couple of weeks, sort of hammer some style information into people? Does that show up at all for you? Can you see anything except a blur in the middle? All right, well, I'm sorry about that. This is an object relational map that was generated by a gem called Railroady. It spits out a dot file that I pulled into several different versions here. What it does is it actually looks at the active record relationships and draws you a beautiful map of them. It's really just a snapshot of how your objects relate to each other and what calls what and where your entanglements are. In the case of this particular one, which you can't see, it shows an extreme, imagine if you will, a hellscape of an organically grown, undesigned Rails app that's about 130,000 lines, and it's been going forever. Pretend that happened. Sorry?
Kind of like one of those 3D pictures.
Yeah, just stare at that blur in the middle.
You start to see it.
Yeah. Either, oh, wait, no. It's there. You've just all had too many beers. That's what's going on. I actually I use this as a guide. When I get new developers on my team, I'll take a map like this, and we'll sit down for an hour or two and just kind of go over it. And that's how I teach them the system. And then they have a map to kind of go by in their day-to-day. And they might not remember exactly everything they go, but they can see, oh, this thing I'm working on, this parts model, has these, this is its schema, and it has this relationship and things. It can kind of pull back out of the code and get a little higher view of where that fits into the rest of the picture. So yeah, give it to your developers. Better yet, go to Kinko's and print it out and put it up on the wall. You know, look at the crap every single day, put it up there. I mean, that's why we do Kanban, right? So we can sort of see, here's the visual representation of, here's our card wall, and here's our code wall. It works. Because honestly, you know, our code is a mess. As developers, all of it is. It's almost all bad. Even if your code is good today, and maybe a little bit tomorrow, maybe not next week though, code is prone to rot, decay, and entropy. A quick fix, a cut and paste, there, and it all adds up. It adds up invisibly until we're left with one of these mud balls. Maybe you want to write good code. Maybe you're, as I said, in the shit and you can't see it anymore. Maybe you're just a lone developer and you don't have someone to pair with who's a senior. You don't have access to a great, strong development, engineering department around you to bring you up along too. Metrics can help with this, every single one of these situations. Metrics, for me, act as a rumble strip along the highway as I'm driving, and it's like, oh, wake up. I'm drifting off course without, like, you know, hitting a wall or something. We're blessed as Rubyists with a very rich ecosystem of these tools, and it's incumbent upon us to leverage them to become better. The tools that I mentioned here today really are just like the tip of the iceberg and the most popular ones. Figure out which ones for you work for you and your team and your projects, the needs that you have. Go out and get Code Climate working. Download the new 3.0 version of Metric Foo. I'm pretty sure it works better. No promises. There's no magic to these code metrics. The tools are really, really easy to get started with. You just run a couple command line things, it spits out some numbers. Use them for a little while, use them for a week or two. Don't worry about the numbers being bad or high or low or sideways. See what they're saying to you. Because in the end, that's what it's about. Our code has a lot to tell us about what came before, what we're doing now, and where we're going, if we just want to listen. And you should take the time and listen to find out what your code is saying to you. Thank you, everybody.